Hello, this is a presentation about dynamic allocation of arrays. In this presentation, we'll talk about how can we allocate two-dimensional array using malloc function. For example, take two-dimensional array. When we statically allocate a two-dimensional array A2 of 2, we can see like this is what happens. An example is given over here where a two-dimensional array example 1 and the elements 1, 2, 3, 4 is stored, and it contains two arrays and two columns. And in this, accessing the array elements would be like, if I say A of 0 of 1, that means it is second element in this array, which is equivalent over here. The index happens at 0th row, that is this is 0th row and this is first row, and this is 0th column and this is the first column in the array A. Another example, if I say A of 0, 1 and 1, then element would be 4. That is first row, this is first row and this is first column. In that, this is what the array element. Now, how can we allocate this particular two-dimensional array using dynamic memory allocation technique, that is malloc function in C? The syntax of the malloc function would be like, this is a name of the function and it returns a pointer to a void, type void, and it takes one argument which is like number of bytes that we needs to allocate for a particular location. On success, it returns a void pointer to that particular block of memory. If memory is not present, then the malloc will return a pointer which is called null. Null, actually null is a pointer, or it is a macro. We don't want to go into detail with what is that null is. So the one point we have to remember is this pointer, void pointer, needs to be typecasted. Let us take an example here. Array is a pointer to pointer of the type integer, and we have to use this malloc in this way, that is malloc, and this is what typecasting, that is we need that particular void pointer to typecast it to pointer to a pointer, because it is two dimension and hence we have two pointers over here. If we want to have a three-dimensional array, then we will have here 3 pointers. So before looking at this particular code, let us understand diagrammatically what this means. When we say a array 5 cross 7, that is row is 5 and column is 7. Now let us take this particular example, array, a diagram, and correlate this diagram, this particular diagram with this code. When we say array, this array, now look at this. How can we visualize this array is two pointer, that is pointer to a pointer. Look at this particular arrow. We have two arrows when we come over here, like two arrows, that is array pointer to a pointer, right? So suppose for example this is also called a array, like it is array which stores pointers only, that is one pointer, second pointer, and third and fourth and fifth. Now when we want to allocate memory for this particular location, then we have to say only one pointer, that is we will traverse only one pointer over here. Suppose now an example, so now if you go to this particular figure to now relate this with this particular variable. Now array is a two pointer, that is int star star, that is we will traverse two pointers. You see here, that is what two pointers over here typecasted, malloc, and rows, number of rows, that is these number of rows, that is 5 here in this example, and size of, that is rows, that would be like 5 into size of int pointer, that is you can say like here we want 5 of the type pointer, that is one pointers, that is you will have like one pointer. I'll show you, that is this one pointer, right? So that is why here single pointer is present. So I'll say array is pointer to pointer typecasting, malloc, rows is 5 into size of this one, actually one pointer, that would be like, it depends on machine dependent, it would be like 2 bytes or 3 bytes, 4 bytes or 8 bytes. So here if you consider 4 bytes, so the total would be total would be like if you take 2 bytes, then it would be 10 bytes of memory would be allocated for this particular rows. So now array here is a pointer to pointer, here it will allocate 5 locations, and each locations is of 2 bytes, that is it allocate 2 bytes. So now we are done with up to here. Now for each of these particular array element, each array element is a pointer to these many columns. So here we have to do at this allocation we need to do. So for that we need to have for loop, then so that is for number of rows, I'll let me clear all these no, okay, it would be like too cumbersome over here, so I hope I am not confusing. So now for each array element, that is a of I, that is how we access this each element, array of I, that is array of 0, array of 1, array of 2, array of 3, and array of 4. So array of 0 is nothing but one pointer, that is we will traverse like one pointer, malloc, columns, that means these columns, that is 7 into size of, now here int, there is no star over here, because when we come over here no pointer is allocated, no pointer is traversed. So here int is nothing but we will store elements in here, not pointer. That is what means in this over here. So array of I, pointer, this is only one pointer, and but this column 7 into size of integer. So this one particular row will be allocated. This is what means. So for each array element, that is for each row, we need to do this for loop. So that is how it's all about 2D allocation. Thank you.